Hi everyone, Assalamualaikum. In this video, we will continue with evaluating composite inverse trigo functions using triangle method, right? Alright, we're still under the second topic in chapter 1, which is evaluating inverse trigo function using triangle method, right? Right now, we continue with example 6 from previous semester papers under inverse trigo function. Use the right triangle method to find the value of cos inverse sine sec2 over 3 plus inverse cot sec2, right? Here are the solution, okay? From the given question here, we are given two inverse trigo function. So, first step, we can let A equals to the first inverse trigo function, and then in column 2, we can write let B equals to second inverse trigo function. Okay, so from here, our A equals to inverse sine sec2 over 3. Sec2 over 3 come together with inverse sine. That's why we let A equals to inverse sine sec2 over 3. And the second inverse trigo equals to inverse cot sec2. Okay, we let B. Okay, sec2 come together with inverse cot. That's why we write B equals to inverse cot sec2, right? Then we can write here, let A equals to inverse sine sec2 over 3 and let B equals to inverse cot sec2, right? After that, we continue with step 2. Change the inverse trigo function to ordinary inverse trigo, right? So, same goes to B, okay? Change the inverse trigo function to ordinary trigo function, right? Right, from here, we move inverse sine to left-hand side, so we will get ordinary sine A equals to sec2 over 3. And we move inverse cot to left-hand side, so we get ordinary cot B equals to sec2, right? From cot B, okay, we can also write sec2 over 1, okay? And from reciprocal trigo identities, cot equals to 1 over tangent, or tangent equals to 1 over cot. If we have cot B, it is equals to 1 over tangent B. Okay, so we can write tangent B equals to, we just exchange numerator and denominator from cot B here. So we can write 1 over sec2, right? We change to ordinary trigo function to easy to draw a right angle triangle and find all three sides, right? So from tangent B equals to 1 over sec2, 1 means opposite, sec2 means adjacent, yeah, for B, okay? And then for A, sine A equals to sec2 over 3, sec2 means opposite, and 3 means hypotenuse. Okay, so from sine A equals to sec2 over 3 and tangent B equals to 1 over sec2, we can draw a right angle triangle in step 3, right? Right, now we continue with step 3. Draw a right angle triangle and determine all the three sides based on trigo function obtained in step 2. Alright, since from the given question we have two inverse trigo here, so we need to draw two right angle triangle. Okay. Alright, from step 2, we find sine A equals to sec2 over 3 and tangent B equals to 1 over sec2, right? From a right angle triangle with angle A here, okay, sec2 for sine means opposite and 3 means hypotenuse, okay? So we put sec2 here, okay? And we put 3 here, right? Then we need to find adjacent using Pythagoras theorem, right? So from Pythagoras theorem, 3 squared minus sec2 squared And after we simplify, we get sec 7. So we can put here, right? Right after that, from tangent B equals to 1 over sec 2, okay, we can draw another right angle triangle with angle B. Alright? To find all the three sides here, first we look at 1 here. Okay? 1 here means opposite because this is tangent. And then sec 2 means adjacent. So we can put 1 here and sec 2 here. Right? Then we need to find hypotenuse using Pythagoras theorem. Okay? So using Pythagoras theorem, okay, we have square root of 1 squared plus sec 2 squared. And after we simplify, we get sec 3. So we can put sec 3 here. Right? Alright. From the previous slide, we done step 3. Okay, we done draw a right angle triangle and find all the three sides, okay, for angle A and angle B. Then we can continue with step 4. Okay, find the relevant trigo ratios from a right angle triangle obtained in step 3. Okay, we find for angle A and for angle B since we have two inverse trigo here. Right? Right. Relevant trigo ratios here means from the given question, we have cos and then in step 1, okay, we have inverse sine sec 2 over 3 equals to A and inverse cos sec 2 equals to B. Means we can rewrite in terms of cos A plus B. And from sum and difference angle identity, if we expand cos A plus B, means we need to substitute the values of sin A, cos A, sin B, and cos B. Means sin A, sin B, and cos B are the relevant trigo ratios to solve this question. Okay, we no need to find the other trigo ratios such as tangent, sec, cosec, and cot, okay, to save our time. Alright? Alright, from right angle triangle here, okay, we can find sine A, okay, which is equals to sec 2 over 3, opposite over hypotenuse. Okay, cos A equals to sec 2 over 3, which is adjacent over hypotenuse. Okay, and then sin B equals to 1 over sec 3, which is opposite over hypotenuse. And cos B equals to sec 2 over 3, which is adjacent over hypotenuse. Right? So from step 4 here, our relevant trigo ratios are sin A, sin B, and cos B. So that we can substitute into formula cos A plus B. Okay? From the previous slide, we done step 4 for A and B. Okay, we find sin A, sin B, and cos B. Right? Then we can continue with step 5. Okay, step 1 until step 4, we need divide by two sections. One for angle A and one for angle B. Okay, and then for step 5, okay, we only have one section. Because in step 5, we need to evaluate the given question. Alright? So therefore, the given question is cos inverse sine sec 2 over 3 plus inverse cot sec 2. Okay? Then we can rewrite in terms of A and B. Okay? In first step, okay, we have inverse sine sec 2 over 3 equals to A. And we have inverse cot sec 2 equals to B. Then we can rewrite in terms of A and B. So we get cos A plus B. So we write here, right? Cos A plus B, right? This is some angle identities, okay? So from some angle identities, okay, cos A plus B. So we refer this formula, okay? If in bracket is plus, means we need to use minus sign here. Right? So cos A plus B equals to cos A cos B minus sin A sin B. Okay, if we use the top sign, so we need to use the top sign for the right hand side. Alright, cos A plus B equals to cos A cos B minus sin A sin B. Okay, so we write here. Okay, cos A cos B minus sin A sin B. Right? And then from here, we substitute the values of cos A, cos B, sin A, and sin B. Cos A equals to sec 7 over 3. Cos B equals to sec 2 over sec 3. And then minus sin A. Sin A equals to sec 2 over 3 times sin B. Sin B equals to 1 over sec 3. Okay, and then sec 7 times sec 2 equals to sec 14, and then sec 2 times 1 equals to sec 2, 3 times sec 3 equals to 3 sec 3, and we have same denominator here, so we can combine together. Alright, so this is the final answer, which is equals to sec 14 minus sec 2 over 3 sec 3. Alright, this is the answer when we solve without using calculator. Okay, if we solve using calculator, we get in decimal. Alright. Alright, up to this point, you can try tutorial 1.1b. The left side, without using calculator, evaluate A, B, C, and D. And the right side, simplify and express in terms of x for E, F, G, and H. Right? Here are the final answer for each questions. Okay? If you have any problem, you can ask me in Telegram. Alright? Thank you. Coming up next, derivatives of inverse trigonometric functions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.